Hey, so in this video we're going to be talking about the angle between two vectors. Now the angle between two non-zero vectors is the angle theta, which is between 0 and pi, as we can see here in our diagram. Here's our theta. And this angle can be found using the dot product. Now it's important to note that the angle between the 0 vector and another vector is not defined. So here, if we're looking for the angle between two vectors, if theta is the angle between two non-zero vectors, let's say u and v, then the cosine of theta is the vector u times the vector v divided by the magnitude of u times the magnitude of v. Let's go ahead and let's try this. So in this example, we're going to find the angle theta between u with coordinates or components rather, 4 and 3, and vector v with components 3 and 5. All right, and so to start this, we want to find the dot product of u and v. So let's go ahead and take vector u times vector v and get an answer. So we should have 4 times 3 plus 3 times 5, which is going to give us a value of 27. And now we want to find the magnitude of vector u, which we can do using our distance formula and our vector components, which is going to give us the square root of 34. And so now we can go ahead and take those and we can plug them in. And that's going to give us that the cosine of theta is going to be 27 divided by 5 times the square root of 34, which is 5 radical 34. Now remember, we're not looking for the cosine of theta, we're looking for just theta, which means that we want to multiply both sides by the inverse of cosine, so that way we can get our theta by itself. And so we have that theta is going to equal the inverse cosine of 27 divided by 5 radical 34, which tells us that theta is going to be approximately 22.2 degrees. And we found our theta. Now, using our equation, cosine of theta equals vector u times vector v divided by the magnitude of u times the magnitude of v, we can actually come up with an alternate form of the dot product. So we can actually rewrite our dot product as the vector u times the vector v equals the magnitude of u times the magnitude of v times the cosine of theta. And what's important to note or to make mention of is that our magnitude of u will always be positive and our magnitude of v will always be positive, which means that if our cosine of theta is positive, then so will our u dot v. And if our cosine theta is negative, then so will our dot product of u dot v. And so that's kind of a cool thing. Now, when we think of angles, we have 4 basics. We have a straight angle, obtuse angles, a 90-degree angle, acute angles, but we also, in this case, can have 2 vectors that go in the same direction and lie on top of each other, which is where our angle would be 0. Now, what do those look like? So if we look at what these 5 possibilities are, here we can see that we've got our when we have an opposite direction, our straight angle, then that means our theta is going to be pi, and the cosine of theta is going to equal a -1. So we've got this little shortcut. So if we know what the cosine of theta is, we at least know what type of an angle we're going to be looking at. We can say the same thing for obtuse angles, except this time our cosine of theta is going to be between -1 and 0, and our theta will be between pi over 2 and pi. Here we have our right angle, or our 90-degree angle, and here we can see that our theta will be pi over 2, which makes sense to us from our unit circle, and our cosine of theta is going to have to equal 0. For an acute angle, our theta will be between 0 and pi over 2, and our cosine of theta will be between 0 and 1. And when we have two vectors going in the same direction, we're going to see that their angle measure, their theta, is going to equal 0, and the cosine of theta is going to equal 1. And so if we're able to find the cosine of theta and break it down, we at least know what type of an angle we're going to be looking for, which can be a helpful thing.